And there was quite some changes compared to the last version of the video how to merge a scan that I did. So let's take a look what I've changed actually. To speak about it, I'm just using some example scan that is a test scan that is a real wheel hub from some Honda. I just left some holes there to demonstrate behavior in merging, and here we are aligned with the scans, and we are, after aligning the scan views, that in this case it's project groups, we are going to mesh the model and create a volume. Okay, so this is the menu you are coming to. This is the meshing menu, and this menu is like some control center for how the mesh will be created. And you will have to let's say be sure that you are fine what you regulated here before you are confirming that step, because in the post-processing this mesh will be the united mesh that is done by the single meshes that scanned before in the project groups, and you will not be able to change that. So of course you can go back to the scan mode, and there you can mesh again, but you will not be able to keep, for example, done operations in the post-process in that case. Okay, so we are right now in that meshing menu. Starting from the top, we have to do the decision what we want to have at the end. Do we want to have a closed model, a watertight model, or an unwatertight model? What you see here as a preview is an unwatertight model. That means that it's not a closed volume, there are holes in it, and that they are not closed. There is advantages and disadvantages in creating watertight or unwatertight model. You will see of them in the following minutes. So I'm just starting with the watertight model because maybe it's for the guys who are 3D printing, the more common way how to do it, and that means we have a closed volume. I'm just going here to mid quality. What is interesting, that is not in the unwatertight model available. I'm just keep the filter like it is. That means filtering out results that are regarding their quality doubtable. I'm just fine with the standard. You can play around with it and see what it does, and you can go back by just going to undo it here, no problem. If you are not sure, it can happen that some areas will, let's say, be less filled with points if you are increasing that value. Small object filters mean if you have here small particles around that you scanned or didn't clean up well, you can use it, and by increasing that filter you will delete objects in a different size. So we are not having, let's say, floating small objects around here, so it doesn't make any difference if we are playing around with that value. What is a really cool feature I was waiting for, and actually I think we had some influence on that, giving that feedback to Shining, is the triangles counter that you have here. Why is it important? Maybe some of you that own that scanner for a longer time and try to scan bigger objects or objects in very high resolution, they have suffered the problem of getting an error message that was most of the times something like you have some unknown software problem, and then your calculation was stuck or the program did close. In any case, you weren't able to continue, and you had spent some hours calculating without a result. What is really something that can be annoying, and you don't want it. So to be sure that you will be ending up in a result that is not too big, you can here limit the amount of triangles that will be calculated. That means if you have here a very high value and a small object, that possible amount of the triangles is much higher than the resolution you scan, so there will be no effect on that counter, so you will not see anything. If you are scanning really big objects and you want to be sure that you can calculate something like a preview showing you if you have captured all the areas that is relevant for you, that will help you out quite a lot. Imagine you're at a customer's place, scan the car, and you want to be sure that all the different views, in this case project groups, are covering the areas you want to have in the merge, and they are working in the merge without deleting any areas or so. You can create here a first calculation, for example, with, let's say, I'm not sure, I just give it some 40,000 will give it some shape. I think 400,000 will be much better, but let's try 40,000. It's depending on the amount of features and surface information, the amount of triangles that you will need to show up a good model with the triangles that you choose. Remove spikes is, let's say, spikes out of the surface that are, let's say, peaky. I'm just going to use it. Marker holes is the scanner markers that I used here. I want to fill them up with auto mode. That's absolutely fine. And we are going right now to apply to see how it will look like. So this will be the calculation of the combined mesh between the different project groups that you will receive right now regarding the parameters that you chose. So you can see that the result is already a decent result, but in this case I gave it not enough polys. I'm just already, let's say, eliminating relevant geometry by doing this simplification. But if I would be out there, just want to see a short result about what I will receive later on, that could have saved me some time and error message and, let's say, struggling. So I'm just giving it more resolution that's permitted. Doesn't matter, I will give it as much as it's needed here, and I will just apply again, so it will recalculate that high resolution. Nothing is gone wrong, no problem, and I will see the result that I would receive in good resolution. And right now you are able to see the full quality of what you have scanned with the resolution that you chose. So it's quite fine right now. What you see, what is still an issue is, unfortunately, if you are going to automatically do a watertight model in this area where there is no complete information of the surface and there is complex changes in curvature, there is still a tendency to create that bulky kind of the holes filling that was in the previous version. So this is something you can deal with in two ways. You can just accept it like it is, go to the next step, delete it out, and just fill it with different functions, even in the appropriate shining software it's possible. Or you are going to use unwatertight, what will be my approach in this case. So in the case of going to unwatertight, the changes will, I guess, not automatically be done. I think I will have to go and redo it, or at least the changes will stay that kind of the fillings inside it. So this is something of the only steps where in this experience you will have to go and undo. So we will see the holes again, and I'm just keeping the standard parameters. You can as well afterwards deactivate it and change something, whatever, but it's absolutely fine. And I'm going to say okay, apply, to see the result. I as well will not go directly to confirm, because I want to see if what I will receive is fine for me. Here we are. And I'm going to keep that resolution that is possible over a maximum triangles filter. I will keep it in a quite high value, because I will show you what is the difference if I don't do it. I don't want to have the size of the model that will be right now created of 3 million triangles and 400 whatever thousand. I just don't want it, but I just show you why I'm not simplifying here over the triangles. There is some difference if you do it right now or if you do it in the post-processing, and you will understand it quite fast when I show you. So right now I'm sure with the result that I have here as pre-result, and I'm going to confirm what sends me automatically to the post-processing toolkit. So right now I'm not able to change the parameters from the meshing anymore, but I'm able to work on that mesh result that I created. You see here, I have here that holes that created some kind of bulky filling ups, and I'm just going to manually fill them in this case because I'm expecting the much better result. Here is 3 different kind of the selections possible. There is flat. I can just show you what it does. It's just flatten that hole by closing it in the easiest way. That means on the borders there is not a respected curvature compared to the new created mesh, and this seems to be the standard parameters that they are using in the watertight model. So this is not the ideal result for me. If I'm using tangent, that means that surfaces that will be connected here will be tangent to the surrounding surfaces, what means that it is as well, let's say, in the borders better approximated. And I can go back and say curvature. That means in polynomials there is a static surface in second degree, and this should follow up that original shape much better, and it does actually. What can happen is that in very let's say unsteady surfaces like here, this, because of bended edges that are of scanning errors, whatever, can lead to some very unsteady surface, and maybe that's the reason why they are not using it by default. So in this case, if I have that kind of strange behavior, I can go back to tangent or straight to see if it's doing the better job, and it does actually. So this is some kind of the try and error procedure to see what is good there. If you're having not too many let's say curvature informations in many directions, tangent is pretty decent and doing the job quite well for most of the cases, and it will look in the end much better than it would have done doing it with that auto function. Okay, here I can try curvature. The hole isn't too strange surrounded, might get the better result, and it does. Curvature, I guess here could be the same. This in 2-dimension bended surfaces should be fine using tangent. This here should be more like a curvature optimized closed hole, and it does. So I'm not going to do all that holes because manually it will take me quite a lot of time. I'm just going to, let's say, close that step, and it's not idle, but it's much better than before. What I can do is after that step close the rest of the holes by auto hole filling, for example, and here I can as well define which kind of the function I use. You are here defining the maximum size of the hole it can happen that it can have, that it will be attended by that algorithm, and that means that surrounding border. So be careful, it doesn't mean a big hole does have a really high parameter, because a big hole can as well have a low parameter if it's radius like, or let's say like a hole, like a round hole. If you have a very long gap, it can have a very high parameter even if it's not a really big surface. So you have to play a little bit around with it. Here in this case I can as well, like before, over apply test what is fine for me, if it's doing the result I want or not, and I can change it afterwards if it's needed. I just put a really quite high value there to be sure everything is closed. It does the job very well, and I'm better off than in the auto modus at least. Of course, if you're using Geomagic or Geomagic Essentials, other kind of the pro software for post-processing and reverse engineering, you might do a much better job. But for a standard free of charge software, that is a really good, let's say, condition. So here be careful, because the right side isn't confirmed like before, it's cancelled. That means you're going to be kicked out of the menu without the changes done. So I'm going to confirm. What next? I'm just used a quite high resolution to go to the mesh. Why I did that? Because here is a simplification as well possible, and there seems to be some difference. That means simplifying here, and I will be able, by pulling the bar, to see how much I will come down in size. For example, I can see here I'm at in this moment in a simplification that will create a STL file with 104 megabyte. That's already capable for many of the CAD softwares. I will have a more curvature based simplification. That's my experience by testing it out. I can show you that. Then if I would simplify from the mesh side already. So I'm going to go to some reasonable size here, and I think working size for a CAD program with a standard RAM, it's absolutely fine to be around, I guess, something, I don't know, let's say 40 megabytes. Here as well, apply and confirm, be careful. It's a bit different. I would rather have to position it a little bit different, but it's like that. And you see right now we are not in 3 million triangles, we are at 844,000 and something. The representation of the geometry that we scanned before is still very high. I still have a lot of surface information, actually much more than I would need for all the standard uses that I have, and I could live with that, so that's absolutely fine. Be careful, don't cancel, confirm. Mesh optimization is something not too much described in the software, but I'm expecting it's doing what it's doing in most of the similar algorithms. That means there will be eliminated needle triangles. That means they are very long and very thin. There will be avoided tunnels, or kind of the, let's say, inverted mesh areas and so on. It's not very well described, but you should be fine to put it something into the 50. I'm expecting, by what I was just shortly studying, it will be fine. It will be some intermediate result between geometry representation and mesh correction, so I will use it. I understand that if you are putting it to 100, there will be the better mesh, but the less quality in surface representation, and you can see that it's just playing around. You can use a bigger or smaller value, whatever you think. I just here did maybe a little bit too much of mesh optimization, and I would be, let's say, in another case not doing it like that. What is the problem? What I'm missing here in this case is, if I directly confirm what I did right now and not click on apply, I'm not able to go back to the step I had before. So if you are putting Ctrl Z, you will not be able to go back. Smoothing is something that's not based on mesh quality, it's just smoothing out your surface. Regarding holes and let's say as well artifacts on the surface, that's really some smoothing that's comparable to grinding some surface with a sandpaper. We can just apply it, don't confirm. That's what you have to really respect. And you see here it's doing quite a well job. There is some areas where I have paint and cast residuals, of the hub that it's not perfectly casted. It's better, I guess, and I will confirm it's absolutely fine for me. So in this case, with this scan, with the possibilities of the software, I'm done. I'm fine here. I have all my options chosen, and of course I can go here and save the scan as an STL, PLI, whatever I need, no problem. And as well, I can as well open for example, a saved file, and at least with an STL mesh from this software or another software, use all the toolkit that I have here on that mesh. So you are as well able, with the free of charge software, to process scan results that you did over photogrammetry or something. So that's quite cool, I guess. Okay, so far that's all for the changes in creating a merged mesh on the new version of the EXScan software. I think it is really a step forward compared to what the status was before, because you are able to work more versatile. You are not so likely coming into the problem of creating a setup in the calculation that will not be able to be calculated by your system or the software, and you will be able to save some time and